In 1963, the Nobel Prize in Physics was awarded to Eugene Wigner, a man whose profound insights into the symmetries of nature redefined our understanding of the quantum world. Wigner, a mathematician and physicist of exceptional breadth, demonstrated that the universe is not just a chaotic assembly of particles, but a symphony of symmetrical patterns. His work not only illuminated the structure of atoms in the nucleus, but also laid the groundwork for future theories in particle physics and beyond. His story is not merely a tale of scientific triumph, but also a testament to the resilience of the human spirit against the tumultuous backdrops of war and social upheaval. Eugene Wigner was born in the bustling city of Budapest, Hungary in 1902 into a family that valued education and intellectual achievement. From a young age, Wigner displayed an exceptional aptitude for mathematics, an interest that was nurtured by his family's encouragement and the complex social landscape of early 20th century Europe. His academic journey was not straightforward. Societal norms and the turbulent political climate influenced his initial decision to study chemical engineering rather than pursue his passion for physics. However, Wigner's relentless curiosity about the natural world could not be stifled. His early education planted the seeds for his later groundbreaking contributions to physics, illustrating how personal and historical contexts weave into the fabric of scientific discovery. The pivotal transition in Wigner's career from engineering to physics was marked by his move to Berlin, where he was deeply influenced by some of the most prominent physicists of the time. As he attended seminars and engaged with the vibrant scientific community, Wigner began to see the potential applications of theoretical physics and its profound implications for understanding the universe. His early work in quantum mechanics, particularly his exploration of symmetry, was both innovative and foundational. It set the stage for his later achievements and established him as a leading figure in the field. This period of his life highlights the importance of mentorship and community in scientific advancement, as Wigner's interactions with other scientists played a crucial role in shaping his path. Wigner's introduction to the concept of symmetry in physics was a defining moment in his career. His innovative use of group theory to analyze the properties of atoms and particles revolutionized the field of quantum mechanics. The Wigner-Eckart theorem in particular demonstrated how symmetrical properties could simplify and solve complex quantum problems. This part of his work not only enhanced the scientific community's understanding of atomic structure, but also provided new tools that would be used by generations of physicists. Wigner's focus on symmetry underscored his belief in the inherent order and beauty of the universe, a perspective that guided much of his scientific and philosophical thinking. Throughout his career, Wigner held several prestigious teaching positions that allowed him to shape the next generation of scientists. His role as an educator was characterized by a deep commitment to his students and a passion for conveying complex ideas with clarity and enthusiasm. The Nobel Prize in Physics, awarded to him in 1963, was a recognition of his significant contributions to the field, particularly his work on the principles of symmetry in quantum mechanics. This accolade not only cemented his reputation as a leading physicist, but also highlighted the broader impact of his theories on the scientific community. Wigner's academic achievements reflect his dual legacy as both a pioneer in theoretical physics and a dedicated mentor and teacher. Wigner's theoretical models and mathematical formulations have had a profound and lasting impact on the field of quantum physics. His work on symmetry principles helped to explain the underlying structures of atomic and subatomic particles, providing a framework that has been integral to many subsequent advances in the field. This part of the essay delves into specific theories proposed by Wigner, exploring how they have influenced contemporary physics and how they continue to resonate in current research. His legacy in quantum physics is not only in his direct contributions, but also in his ability to inspire new ways of thinking about complex problems. Wigner's involvement in the Manhattan Project during World War II marked a significant, though controversial, phase of his career. His decision to contribute to the development of the atomic bomb was driven by the urgent political and ethical dilemmas of the time. This part of the essay examines his role in the project, his collaboration with other scientists, and his reflections on the ethical implications of his work. His experiences during the war underscored the complex relationship between science and society, a theme that would continue to influence his career and philosophical outlook in the years following the war. In his later years, Wigner continued to contribute to both the scientific community and efforts toward disarmament and peace. His advocacy for nuclear non-proliferation and his involvement in international scientific dialogues underscored his commitment to using science as a force for good. This part of the essay reflects on the awards and recognition he received, his final contributions to physics, and the enduring impact of his work. Wigner's legacy is characterized by his profound contributions to theoretical physics, his ethical stance on the use of scientific discoveries, and his role as a mentor to future generations of scientists. Eugene Wigner was not only a physicist, but also a philosopher of science, deeply interested in the implications of scientific discoveries for our understanding of the world. His philosophical contributions, particularly his ideas about the symmetry and beauty inherent in nature, have influenced both theoretical and philosophical physics. This part explores how Wigner's philosophical views influenced his scientific work, and how his thoughts on the nature of reality continue to provoke discussion and inspire researchers in various fields. Throughout his career, Wigner was in close contact with many of the most influential scientists of the 20th century. This section explores his relationships with figures like Albert Einstein, John von Neumann, and others, examining how these relationships influenced his work and the development of quantum physics. Comparative analysis of their contributions offers insights into the collaborative and competitive environment that drove much of the innovation in physics during this period. This part of the essay highlights the importance of intellectual exchange and community in scientific progress. As a professor, Wigner was known for his exceptional teaching abilities, characterized by his clear exposition and deep understanding of complex subjects. This part of the essay explores his philosophy on teaching, his impact on his students, and his overall contributions to education in physics. Discussions of his notable students and their subsequent achievements illustrate Wigner's influence as a mentor and highlight the continuity of knowledge and ideas in the scientific community. His teaching legacy is integral to understanding his broader impact on the field of physics. Wigner's development of mathematical tools and frameworks was central to his contributions to physics. This section delves into the specific mathematical techniques he pioneered, such as the Wigner-Eckhart theorem and the application of group theory to quantum mechanics. Exploring the significance of these tools not only in his time, but also in contemporary research, this part highlights the enduring relevance of Wigner's work and his unique ability to fuse mathematical rigor with physical intuition. The concept of symmetry remains a cornerstone of modern physics, influencing contemporary theories and research. This part of the essay examines the ongoing impact of Wigner's work on symmetry, exploring how his ideas have been developed and expanded in fields such as string theory, quantum field theory, and beyond. Discussions of current research and future directions provide a perspective on how Wigner's legacy continues to shape our understanding of the universe and its fundamental principles. Eugene Wigner was deeply concerned with the role of science in society, advocating for responsible use of scientific discoveries and thoughtful consideration of their implications. This part of the essay explores his views on science policy, his contributions to debates on ethical issues in science, and his influence on public understanding of scientific matters. By examining his reflections on the intersection of science and society, this section highlights the broader themes of Wigner's career and his commitment to integrating scientific progress with ethical considerations. The story of Eugene Wigner is a compelling narrative of intellectual brilliance, profound discovery, and ethical contemplation. His contributions to physics, particularly through his exploration of symmetry, have left an indelible mark on the field, influencing generations of scientists and reshaping our understanding of the universe. As we reflect on his legacy, it is clear that Wigner's work remains highly relevant, providing the foundations for ongoing advances in physics and offering insights into the philosophical implications of scientific inquiry. His life reminds us that science is not just a pursuit of knowledge, but a deeply human endeavor intertwined with the complexities of history, society, and individual experience. Eugene Wigner's story exemplifies the quintessence of intellectual transformation, a journey from the tangible world of engineering to the abstract realms of quantum physics, driven by an unyielding quest for understanding the underlying principles of the universe. His exploration of symmetrical patterns in nature not only revolutionized our grasp of quantum mechanics, but also illuminated paths for future theoretical exploration.